So you heard a lot of new ideas yesterday, solving equations using logs and bases. I want to use today as a chance to revisit, make sure that you're hearing and applying these concepts correctly, and then you'll get a chance to practice a little bit more in depth on the other side of this paper. Now, I know you've seen this before, so I'm not teaching it like you've not heard it, but we're just going to make sure that you're hearing it correctly. So if you have a basic exponential, don't forget, exponential just means that x is in the exponent. So if x is in the exponent, you got to convert. You got to use logs. In fact, you got to think like a log, knowing that this problem is really a log base 7 of 60. So if x is in the exponent, we're going to use logs. And if it's basic, all we got to do is convert it, because ultimately this problem just means dividing the log of 60 with the log of 7. You do that on your calculator. Make sure that you're doing that correctly. That is part of the deal here, and you get 2.104. Now, if you have more of an advanced exponential problem, then, as I like to use the language, you're going to want to slap it with a log. When you slap it with a log, you're doing that to both sides of the equation. So what we want to do is we want to isolate the exponential part. We want to isolate the x part, and doing things like adding 5 as an initial step, pretty basic, pretty common, but you need to do that first so that you end up getting that 4 to the 2x all by itself. Now it's time to slap it with a log. Now when I do the log of both sides, what that does is it causes this exponent to come tumbling down. And that's really the whole idea here, because x is up in the exponent until it comes tumbling down in front of the log. Now I've got the log of 4 and the log of 48, no big deal. I'm just going to end up dividing them anyway. So we divide both sides by the log of 4. Again, a common calculator procedure to take those two logs and divide them. You're going to end up with a decimal. When you get 2.792, just kind of keep that number on your calculator, because all you got to do is divide that by 2 as, of course, the last step for solving for x. Kind of running out of space here, but you end up getting half of that number, which is about 1.396. Now, if x is in the exponent, but you see e, yes, you're going to slap it with a log, but it's going to be a natural log. And before you get too carried away even doing that, you still need to isolate. And so doing a little step in the beginning here, again, the initial step of just isolating, divide by 2, we get 44. But as I said, if you see e, you're going to slap both sides with a natural log. Now, natural log is just a special log that cancels with e, because it is a base e logarithm. We didn't get a lot of time to talk about that, but I still want you to know that that's what you do. And when you do the ln of 44 on your calculator, make sure you use the ln button, and we get 3,784. Okay, and of course, when you subtract 2 from that, you'll be down to 1,784. So, if you see an e, you're going to still isolate it, but then you slap it with a natural log. Those are exponential equations. X is in the exponent. But if you have a log equation, you're not going to use a log to cancel a log. You're actually going to use a base, as we called it yesterday, the ace of base, but you're going to base it. So if I have the, like letter D says, the log base 5 of x minus 2 equals 3, I don't want to do something silly like do the log of both sides. That actually doesn't make any sense. Instead, I want to base both sides. And since this is a base 5 log right here, I'm going to base both sides with a 5. Now, when you base with a 5, it cancels with the log. That's the whole reason you did it. But you also get now 5 to the third power. 5 to the third power, that's like 5 times 5 times 5. You got to calculate that, of course, to be 125. So when I do a base to both sides, I end up causing the other side of the equation to raise up like an exponent, 5 to the third power. Now, the last set of problems, I call them advanced logarithmic, probably the most complex that you'll see, but if you keep in mind that you're trying to condense to a single log, that is the main procedure, condense to a single log. You won't find yourself doing something silly. Something silly on letter E would be like kind of saying, well, I'm gonna base everything with a base E. Isn't that right, Mr. Naylor? It's not the right time. Okay, so you can't throw a base at 2 logs. Instead, you have to condense. Now, condensing is this specialized procedure where you start moving things according to the properties. You start moving coefficients, for example, up as an exponent. What do we get then? We get the ln of 2 to the 3rd power, which of course is the number 8. Now, other things that we need to do here, we need to recognize, and this is the main thing, that there are 2 logs in this problem. 2 logs need to become 1 log. How do you make them become 1 log? You write 1 log. You condense to be 1 log. You use the properties. And the properties say that you're going to multiply these circled items because you are adding. And so when you multiply those circled items, you end up with 16x. Now, that was a property of logs from a couple lessons ago. But now we can undo, we can base both sides. We can undo the log with a base e. Now, why am I using a base e? Because that's the one that's going to cancel with an ln. And, of course, that leaves us with just the 16x. It also leaves us with e to the 3rd power. Now, e to the 3rd power, that's something you want to do on your calculator. Make sure that you can find that e button and double check that you get right around 20 with some decimals. But you can leave that on your calculator because all you're going to do is divide it by 16 anyway. So your final answer ends up pretty close to about 1.255 as we try to round to 3 decimal places. Take a look at letter E again. We condensed using the properties to 1 log, and then we base both sides. So again, as you look at a problem like letter F, don't try to just base everything right away. Okay, it doesn't work that way. If you see multiple logs, like on this side of the equation, you got to condense them to be 1 log. How do you condense them to be 1 log? You write 1 log, and here we have subtraction. So remember, whenever there's subtraction, it's going to be a fraction. Whatever's being subtracted is going to end up in the bottom of your fraction. And then the only thing left is the guy that's being added, that's our x plus 2. I know, it's a little tricky, but we had subtraction, so we made a fraction. Now, it's fine that we have a log on each side of the equation, but the point is that it's 1 log on each side of the equation. So now I can base both sides, and I'm going to base both sides with a base 4. Haven't seen this yet. I didn't show you one like this yesterday. It's actually kind of nice because both logs cancel out. That's right, both logs cancel out, and it leaves me with just the algebra equation that I have to solve using inverse operations. Now, make sure that your inverse operation would be to multiply both sides by the denominator, something that you've seen before, but you want to multiply carefully because that's actually going to use the distributive property. So it looks like we're going to get like a 6x and a 3. We still have x plus 2 over here, but you move some numbers side to side, do a little bit of inverse operations, and I think we get 5x equaling -1, which means x equals -1/5. So if you have multiple logs, you have to condense them, and then you can base both sides. Now, when you flip over to the other side, the idea here is to start to get more confidence and obviously start to get more problems correct. I am going to provide a selective answer key that you can check to get you ready for the mini check.